Okay, so let me share my screen and then. So we have completed that triangles chapter, right? And that last question was troubling one, right? So did you go through that question again? Did you go through that question?
Yeah, I am it.
Okay, so yeah, and do you have any doubts in that question?
Oh no.
Good. So now let us start this new chapter, which is circles, right? Okay, so what we already know about circle? What is a circle? Do you remember?
So every day the class is at 6 now?
No, no, no. So yeah, today only it was scheduled 6 o'clock, but yeah, next class that will be the usual time. Okay, the Learnivio team will tell you about the timings, right? Because yeah, I don't know even the timing, so they will just provide you the earlier information. Right? What would be the time, whichever would be feasible. Okay. Okay, so we will start this circles and what is the prior knowledge that you have of circle? What is a circle?
It's a closed figure.
Yeah, it's a closed figure. Yes, one that is correct. But what is the what are the other information that you have?
There's radius, diameter, chord,
Yeah.
segments, all these things.
Okay. Yeah. Obviously. So the thing about the circle that it is a closed figure and whose outer perimeter is at a at an equal distance from a particular point which is called the center, right? So this outer perimeter is always at equal distance. All these points, all these circles are at equal distance from the center. So that is what we call a circle. Whenever we have all those points which are at equal distance from a single point. So that figure, that closed figure would be called a circle. Right? So circle has one thing which is a radius. Right? Let's represent it by R. Then it has a center, which is O. And then it also has this diameter that you have just told me. So diameter, and then it has a chord, right? By let's say denoted by AB. And yeah, these are the useful things that we have in a circle. So in this chapter, what are the extra things that we have to understand? Right. So let's say we have this circle, right? And we already know about the radius, the diameter, the chords. And let's say if we choose if we take some line, right? So let's say if we take these lines and this and this one also, right? So we see that all these lines, this one, this one, this one, this one, and this one, all these lines intersect this circle at points, right? But whenever we closes these distances, right? So in the first case, this was the distance between the 2 points. If we did decrease these 2 points, right, in such a way that these 2 points become one, So earlier, what did you see? That this circle is intersected by this line at 2 points. And when you take the separation of these 2 points closer and closer, and then the separation becomes zero, so you will have only 1 point, right? So when the line intersects the circle at different points, so that is called secant, right? That is called secant. And when the line intersect the circle at 1 point, so that is called tangent. So tangent is a line which intersect the circle at 1 point. And secant is a line which intersect the circle at 2 points. So that is the difference between tangent and secant. Is this clear?
Yes.
Okay, so this is one thing, right? And the other thing that we have to understand in first exercise, and this is the first theorem. So I will not write the definition. Now you already know what are these things, right? So I will not write the definition. The first theorem that we have to understand. This is theorem 10.1. And what does it say? So let's say if we have this circle and we draw a tangent at this circle, right? So this tangent will meet this circle at this point, intersect this circle at this point, and this point is called the point of contact. So the point on this circle where this tangent intersects this circle, that is called point of contact. So if you take this point of contact and you have this center, so if you join this center with this point of contact, so that would be the radius, right? So the radius joining the center and point of contact, that radius would be perpendicular to this tangent, right? So this is the first theorem. So it says that the radius joining the center and point of contact would be will be perpendicular the tangent containing the point of contact, not the other tangent, right? Which have a different point of contact, not this tangent, right? Only the same point of contact tangent, the tangent containing the point of. And as you already know, what could be the next theorem? What could be the next theorem? So the next theorem is converse of theorem 10. What does it say? So it states that if you have a tangent, right, and you draw a radius on this point of contact. So if the radius is perpendicular to this tangent, right, or if this line is perpendicular to this radius, then it would be a tangent, right? So first theorem states,
Can you
first
say
theorem,
again?
yeah, first theorem states that if you have a tangent on a circle, then this radius would be perpendicular to this tangent. This is first theorem. The second theorem states that if you have a line, which is perpendicular to this radius, then this line would be a tangent. So that is the second thing, right? In the first
Okay.
theorem, yeah, first theorem talks about the tangent and radius, which will be perpendicular. And in the second theorem, it is already given that it is perpendicular. So if it is perpendicular, this line is perpendicular to this radius, then this would be a tangent. So that is the theorem point, right? And remember, not this line. Right? This line is also perpendicular to this thing, but this is not the radius, right? We have to take the full radius. Okay, so these are the two things that we have to understand in the first exercise. Please note down these, right? So the first exercise talks about secant, tangents, and the first theorem. Please note it down.
For the second theorem, can you write the statement?
Okay, yeah. So I will write this part. Yeah, did you note down this part? Theorem 10.1, did you note it down? Yes, let me write down the statement. So it states if the radius which contains or which if it states if the radius made by joining the point of contact and the center is perpendicular or line, then that line would be a tangent. So that is the second. Yeah, whenever you have completed putting down, please let. Yes, noted, Rifa.
Yeah, I'm writing now.
Oh, you're writing. Yeah, whenever you have completed, please. Yeah, whenever we have completed.
We have finished.
Finish. So now let us do some questions, and then we will talk about the other theorems. Okay, so uh, yeah, they have not told in like theorem 10.2. They have just written this theorem 10.1. So yeah, we have to write the wordings as well, right? So 10.2 they have not written. So when we will talk about theorem 10.3, so from the book that would be 10.2, right? So that we'll talk about later. And this
So there are
sometimes,
just two theorems, right?
yeah, yeah. So in this one, the one is also talking about the other theorem which is related to the point outside the circle. So this theorem they have not talked about that I have told you the 10.2 theorem, right? Yeah, they have not talked about that theorem. But you remember, right? You remember that whenever a line which is perpendicular to this radius, then that line would be a tangent. So that is the other thing, right? Converse. Okay, so let us do some questions based on this thing that we have understood. Let us do some questions. The first question is that how many tangents can a circle have? How many tangents can a circle have? Yes. How many tangents
How
can you?
many?
Yeah. How many tangents that you can draw in a circle?
We can draw many,
Many,
but
right? So the answer, yes,
infinite.
yeah. So the answer is that many or infinitely infinite. We can write infinite. We can write many. Right. Many means that we can count, but we cannot count, so that is infinite. Right? Or we can also write infinitely many. That we can also write. So this is the infinite. Now a tangent to a circle intersect it in how many points?
1 point. Tangent on one.
This is 1 point. A line intersecting a circle in
Secant.
that is a secant. Yeah, that is also correct. A circle can have how many parallel tangents at the most?
2.
Two. Right. So let's say you draw a tangent this one, and you draw another tangent this one. So these are the two parallel tangents. And now can you draw any other tangent which would be parallel to these two? Any other?
No.
Right. So only two parallel tangents, right? Because this one would not be parallel. This one would not be parallel. This one would not be parallel. Only two would be parallel. Okay, so this is done. The common point of a tangent to a circle and the circle is called. What is the common point of tangent? So
A chord.
this is the tangent. This is the point of tangent. This is the point of circle. This point is common. What is this point called?
The point of intersection.
Point of contact, right? Point of
Oh,
contact.
wonderful.
So this is, yeah, that is a point of intersection, but that has a specific name, right? This is point of contact. Point of contact. Now, let's draw a line and two parallel lines to each other, and one is tangent and the other. Let's say gives it this. The third question is so a tangent PQ at a point P of a circle, right? So we have this tangent, and at a point P of a circle. So this P is there for right. So this P is also in tangent and this P is also in the circle. So this P is point of contact, right?
Yeah.
And then we have this another point Q. So this PQ is a tangent. And what else do we have? So of a circle of radius 5 centimeters. So radius, we, this is 5 centimeters. This is the radius, right? And what they are saying, so OQ, they are saying that this OQ is 12 centimeters, right? So we know that what is this angle? What would be this angle?
Right angle.
Right angle, right? So what kind of triangle is OPQ?
It's a right angle triangle.
Right angle triangle, right? So in right angle triangle, this 12 is what? OQ is what?
Hypotenuse.
Hypotenuse, right? This
Yeah,
is
5 is the
hypotenuse.
perpendicular. So we
Yeah,
have to use the Pythagoras theorem.
absolutely right. So use Pythagoras theorem and tell me what would be P. Use it and tell me what would be P.
We got root 169, which is 13.
169. Oh, are you getting 169? So what is the Pythagoras theorem? Pythagoras theorem says that perpendicular square plus base square,
Yes.
that would be hypotenuse square. Perpendicular is 5 square. Base you don't. Hypotenuse, base square, that would be 12 square minus 5 square, right? So this would be how much?
Oh,
140.
okay. I plussed it. I remember.
Yeah. So that would be 1 9. So this would be the answer. Yeah, please correct that and then we'll talk about. Yeah, so I will write that as theorem 10.2, right? Please forget about this theorem 10.2 that we discussed. That we will remember, but we'll not write it like theorem 10.2.
Yeah, finished.
Finish. Okay, so now let us discuss about this next exercise, right? And what does it tell? So, yeah, this is actually not the theorem 10. This is another theorem which is converse of theorem 10. So the
Yeah,
theorem
but
10
this
point,
converse theorem is not in the textbook, right?
yeah, this is not in the text. So this will, so the next theorem that we have, right? This is theorem 10.2. And before we discuss this theorem 10.2, let's discuss that how many tangents we can have if we choose points, right? So let's say we have this circle and we choose a point. So there can be three scenarios, right? One, that we can choose a point inside this circle. The other is that we choose a point on this circle, right? And the other is that we pick a point outside the circle. Outside could be here, 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 in everywhere we can take. And so there can be three scenarios in which we can pick a point. So let's say if I pick a point inside this circle, then how many tangents I can draw? Inside, how many tangents I can draw? If I pick this point, how many tangents I can draw?
Inside or outside?
Inside, inside.
One.
What would be that? How can you draw a tangent from here? How can we draw that? Let's see. We can never draw, right? We can never draw any tangent from here because that would always be intersecting, right? That
No,
would
but
be,
from theorem 10.1, we know that the radius when it joins the center, when it will be perpendicular to the tangent.
yeah, yeah.
Mm.
So if I make a line at this point, so that would be this. So that would always be intersecting at 2 points, right? If I take this point, so that would always be intersecting at 2 points. If I pick this line, so that would always be intersecting at 2 points, right? Clear?
Tangents are only formed outside.
Yeah, so from inside we can never draw a tangent, right? So from inside there would be zero tangent. Now if I pick a point on this circle, so on this circle I can always draw one tangent. Let's say if I pick this point, so I can draw one tangent. If I pick this point, so I can draw one tangent. So a point on this circle, I can always draw one tangent. Is it clear?
Yes.
And let's say if I pick a point outside this circle, then I can draw how many tangents? Two tangents I can draw, right? And then I can only draw two tangents, not more than that. Is it clear?
Yes.
So from a point outside the tangents, I can draw tangents, but there is a relation between those two tangents. So that relation is given by this theorem 10.2. So let us study that theorem, right? So let's say we have, what does it say? So it states that if we pick a point outside the circle, right? Let's say this is B, this is B, this is A. So tangents can be drawn from a point outside the circle. Length would be its length would be equal. So it states that if this PA and PB are tangents, if PA and PB are tangents, right, then PA would be equal. So this is what theorem 10.2. Is it clear? If this PA and PB are tangents, then these would be equal. Is it clear?
Yes, yes.
So now let us derive this thing, right? So how come they are equal? So let us understand. We have this. point. This is the point. B, C, E. Let's say this is the center that we have. So if I connect this center and this point of contact A, so what would be this angle? What would be this angle? Yes,
Yeah, it
this is,
will nine
yeah,
90.
90, right? Because this is a point of contact and we are making a radius and that is the tangent. So this would be 90 degrees. Similar thing would happen if I connect these two, right? So let's say this is O. Now you tell me that let's say I connect this line, right? I connect this line.
Right angle triangle.
Yeah. So these two are right angle triangle, right? So these two are right angle triangle, and I take two triangles, right? I take two triangle. One is this one, and the other one is so these two are the triangles that I choose. So what I can write in triangle OAB and OBB. What do we have? We have what are OA and OB? What are OA and OB?
Perpendicular.
Yeah, OA and OB are perpendicular, but from the circle, what are OA and if you connect the center from the point on the circle, what is that? If you have
Um,
a center and you connect this point, so what is this thing?
oh, that's radius.
Radius. So OA and OB are radius, right? So OA equals to OB, and what are that? This is radius. Okay, I should not write this thing first, but I will write this thing later. First, let us write that angle OAB, AB that is equal to angle OBB, each 90, right? And then OB equal to OP. What is that? That is common. And then I write this thing OA equal to OB, these are radius of the same circle. I will not write this part. These are radius. Okay, so you have a 90-degree. OP is the hypotenuse, right? OP is the hypotenuse, then this OA is the side. So then triangle OAB would be congruent to triangle OBB. And what would be the criterion? If you remember, what would be the criterion? Yes,
Oh,
yes.
SAS.
SAS. For SAS, we need this thing and this thing. But we don't know about PA. Or
But
even
the side is equal, right? I mean, the side is equal to OB and OP is also equal, and there's like an angle.
AP and BP that we have to write. That is the theorem that we have to. Yeah, but they are not equal yet, right? We don't know about them.
RHS?
RHS, right? So absolutely correct. So they are congruent by RHS. We have a right angle. This is the right angle. We have a hypotenuse. We have a hypotenuse. Then we have a side. So by RHS, they are congruent. So then what we can write? Then we can write PA equal to PB by P. That is how we prove that why these tangents are equal, right? note as note that part, and we can also write. Yeah, so also remember that these two angles are also equal. These two angles are also. Let's say if this is 1, so this would also be 1. If this is 2, so this would be also angle. I will write that part, angle A. This is not needed, but we will use this thing in the later parts. Angle by CBCD, and also angle AOB. This is angle by CBCD. Please note down these parts, and then yeah, talk about one more thing, and then we'll start. Please note it down. Yeah, whenever you want me to scroll down the screen. Yeah, whenever you want me to scroll down the screen, that Yeah, Rifa, noted.
Yeah.
Yeah, this part, did you note down this part also? Yeah,
Uh,
noted.
1 second. The last.
Oh yeah, please. This was right. Yeah. Whenever you have noted it down, please tell. Then we'll talk about one more concept and then we'll start the things.
Yeah, finish.
Yeah. Okay, so the next thing that we have to remember in the circles chapter, the next thing that we have to remember is that if you draw this tangent from the point outside, right? This is point B, and if you make a quadrilateral out of it, right? So we know that how much is this angle?
90.
This is 90. This is 90. So these two angles, right? This
180.
is yeah. This is OAP B. So in quadrilateral OAPB, right? We know that angle A is 90 and B is 90. So we know that angle A plus angle P plus angle B plus angle O. How much would be this? In a quadrilateral, how much would be this angle?
180 degrees.
360. This is a quadrilateral, right? So angle A
You're
is
asking only the triangle or the whole circle?
this OAPB. OAPB is a quadrilateral, right? I was talking about OAPB, quadrilateral. So quadrilateral inside angle is 360, right? A is 90. B we don't know. B is 90. Angle O we do. So if we write angle P plus angle O, so that is 360. 90 plus 90 is 180. This goes in the other side. So that would be 180. So in this quadrilateral, in this quadrilateral, these two angles are supplementary. So let's say this is 1, this is 2. So angle 1 plus angle 2 will be 180. Always remember this. Okay, quickly note it down and then we'll start the exercise. Is this clear to you?
Yes. This includes the theorem 10.2.
No. So this is different from theorem temple. This is another concept. It's totally different from yeah, this thing that we have to remember that if you join this external point and you make the tangent, those two tangents, and then you make a quadrilateral out of it. So then in this quadrilateral, the opposite angles would be complementary, supplementary, right? So this is supplementary. Yeah, whenever you have noted it down, that
Yeah, finished.
Then let us start the next exercise. Oh yeah, and remember you have this class assessment also. In that class assessment, you have this topic which is triangles. The first topic of triangles, you have, right? Yeah. So whenever this class is over, please take that test.
This
Yeah.
class, this one has to be done today itself.
Yes, this has to be done what? After this
Today,
class.
today it's like till what time?
Yeah, so after 3 minutes, right? We have more minutes, and then we'll stop this class, and then you can leave, and then please take that class. So the first question. So choose the correct option and give justification, right? So we have from a point Q, the length of tangent to a circle is 24 centimeters. And yeah, so there are people who are joining, right? Okay, so we have this point Q, right? And then we have this tangent, which is what? Which they have not mentioned. Let's say that this is A. And we have this center, right? Okay, so there are people who are joined, right? Galvin. Okay, so yeah, this is given that this is the center. So the center is 25. This is 24, right? So tangent length is 24, and this is 25. So what would be this thing? We know that using the Pythagoras theorem, this would be 24 square. That would be 25 square, right? So we write this thing as 25 square minus 24 square. So this would be how much? This would be 625 minus this is how much? 576, right? So we can write this thing as, or we can also, yes, this would be how much? 9, and this is 11, 7. So x would be 7 centimeters. So this would be 7 centimeters, right? So we'll stop it here, and yeah, we'll stop and see you in the next class, right? Talk about this chapter, the exercise next. Okay. Yes, Rifa, can you hear me? Yeah, so we'll stop here and see